Hello, and thank you so much for tuning in to our presentation today. We are very honored to be part of the inaugural LRVS. My name is Corey Cheeks. I am an independent industry consultant, and I'm very grateful to have an esteemed colleague alongside me virtually for this presentation today.
Hey, thanks, Corey. My name is Cody Evans. I'm an ExxonMobil lubrication engineer in the Houston area, covering Houston and Beaumont.
So the title of our presentation, and this is some really cool data that we're excited to share with you. I hope you think it's as cool as we do, but the title of this is Using Bearing Temperature Trends as an Indicator for Oil-Related Deposits in High-Speed Turbo Machinery. Now, admittedly, that is a long title for a presentation. So what do we really mean by that? Well, to express this a little more visually, we are starting to learn how to use this, trends of bearing temperatures and other machine diagnostics. So using this to predict this, oil-related bearing deposits. And these are deposits that likely would have otherwise gone undetected with traditional techniques. Now, again, we're still learning. I don't think we can claim that this is a perfect science, but we have documented many excellent correlations between the bearing data that we'll share in this presentation and with actual confirmed oil deposit issues in field applications.
So the first thing, a lot of times people will explain this phenomenon as varnish. Now, there are actually at least two different types of varnish that we commonly talk about in the industry, and we use this catch-all term as varnish. But the a lot of times when we're talking about varnish, we're talking about gas turbines and varnish that's showing up in servo valves, control systems, sometimes steam turbine governors or things like that. And it's basically varnish that's created in the oil because of some hot event or some hot bearing or something like that, that is then spreading to the rest of the system, and these submicron particles are settling out in the cooler, low flow areas. It could be in a reservoir even, but typically servos are where we would see a classic varnish situation, or what I like to define it as cold varnish. On the other side, when we're looking at hot varnish, Corey, if you want to advance that, thanks. The hot varnish is where a bearing would show, or a varnish would show up inside of a bearing. This would be also known as a high-speed bearing deposit. And so throughout the rest of this presentation, we're focusing mainly on hot varnish. Cold varnish is pretty well studied. It's something that we, can combat with, regular oil analysis or advanced oil analysis. And there's varnish mitigation that's pretty well known throughout the marketplace. Hot varnish, on the other hand, is where we have this, a hot spot where a bearing is cooking or oxidizing oil in the hot spot, and the oil is sticking, or the deposits are sticking in that exact hot spot. This could be on journal bearings, thrust pad, tilt pad bearings, pictured on the right-hand side. Lots of different reasons for this. When we're looking at bearing temperatures are one of the best indicators on if you're likely to get hot varnish, and also if you already have hot varnish. The location where we're taking these temperatures from is the API 670 location. So it's on the backside of, it's basically the hot spot of a bearing. You can dig into what that means if you're not familiar with API 670. But the magic number for hot bearing deposits that we've found, just as a general rule of thumb, is about 180 F. If you have turbo machinery running where the bearings are at or above 180 degrees F, and higher speeds make it even a little more likely, it's likely or possible that that you could start creating these hot bearing deposits. And it's more of a mechanical phenomenon. You know, some oils might do it worse than other oils, but in most situations, that 180F range is where you'll start to see it being created. And why does this matter? A lot of times people will run a long time without even knowing they have hot varnish issues until they open it up. But as you start insulating this bearing with this varnish, right, you create like a lacquer finish on the bearing itself. It will insulate the bearing, and the bearing temperature will go up, up, and up. And that up around 270 is where we start to see babbitt creep, or basically your babbitt starting to deform. And in between there, you have the alarm and trip temperatures. Those are general rules of thumb. Some people don't even run trip temperatures, and that's fine. But those are the temperatures we're looking at. So 180 up into that 230 range is really where action needs to start being taken. Next slide. As I said before, varnish or hot bearing deposits is more of a mechanical issue, right? So it's because a machine is already running hot, or maybe there was a temperature excursion, some sort of event, cooling water wasn't turned on or something like that, and to where we start creating these deposits. It could be improper tolerances and things like that as well. So first of all, the root cause is to address the mechanical concern. Now, some compressors and steam turbines, they are going to run hot. It could be because of process, could be because of speed or design or whatever it is. And there are, I guess, fixes, mechanical fixes to that. They include opening up the bearing tolerances. You can offset the pivots where you add more of an angle of attack, so you force more oil into the bearing itself. There's directional lubrication where you're actually spraying oil into where the pads would be. And then you can also change the metallurgy of the bearing, give it a copper chrome backing so that it cools faster. These are all mechanical tricks. Bearing designers can help with this. These are things that should definitely be explored, but they're only things that can be done at downtime. In the normal running life of a turbine, you may go 7 to 10 years without ever bringing this machine down. Next slide. And so detecting it and understanding it while it's running becomes key, right? It's one thing when you open up a bearing and it looks like the bearing that's pictured up above. It's another thing when you've gone for years and years and you look at your oil analysis data. For those familiar with oil analysis, we have MPC up here of a 6, which is great. Ruler for the amine is 76%, which is great. Total acid number 0.06, which is great. And we look at the data itself, and we have this temperature excursion where there's an event happening, or there's a bearing that's becoming more and more insulated, and the bearing temperatures are climbing up. And they're not only climbing up, and you can see it's well up above into the alarm and alert range, getting very close to trip if there's a trip on this. But there's also a sawtooth pattern that kind of comes in, which Corey's going to talk about. So I guess the point here is oil analysis oil analysis should be coupled with looking at actual bearing temperatures and trending those. It's not the end all, like sometimes we use oil analysis for cold varnish as an end all.
Yeah, thanks, Cody. So here's another real example of correlating bearing temperature to actual observed bearing deposits. Again, in this case, the routine oil analysis was completely normal, yet you can see the extreme bearing temperature excursions that were taking place in this trend. And again, the deposit, the high-speed bearing deposit, was confirmed when this machine was able to be visually inspected. Here's an example of this characteristic bearing temperature signature when oil-related deposits are present, or the tendency to form bearing deposits is present in the fluid. This has been described as sort of a sawtooth pattern. If you look closely, you'll see these extreme, very sudden temperature spikes or excursions that are taking place in this bearing. Even though these excursions seem to spike very rapidly, very suddenly, and then reset, over time, you'll see that there is a clear gradual increase in the overall mean temperature. Now, this is a long-term trend. What you see on this slide is a 500-day trend. If you zoom in on that a little bit, here's a shorter-term 30-day view of the same bearing. So you can get a closer look at what these sawtooth-like temperature excursions look like. The bearing in question here is the red line on this graph. And again, this is very characteristic of the temperature signature that we have observed in high-speed bearings that are experiencing oil-related deposits. So here is an example of using, Cody mentioned some mechanical fixes or mechanical approaches that can be used to address this issue. There are also some oil chemistry approaches that can be used to address these oil-related bearing temperature excursions. Now, before I get into the data, I should probably preface these comments by saying that normally we do not advocate adding anything to your oil, but if it's done with careful analysis in planning under the right conditions, if you do compatibility analysis and possibly even some laboratory simulation, we have observed that it's possible to have a positive impact on bearing temperature with this oil chemistry approach. So what you see here is a real life example. This was from a refinery wet gas compressor where the routine oil analysis was completely normal. Even the advanced oil analysis was normal. The MPC was 2, so varnish was practically non-existent. Yet we observed the bearing temperature excursions that are shown by the blue line on this graph. So we did use an oil additization technique to enhance the solubility properties of the oil, and we saw a very positive impact on the bearing temperature trend, as you can see indicated after the green arrow here on this slide. Here's one more real life example. Again, the routine oil analysis was completely normal. The advanced analysis indicated perhaps some marginal risk for deposit tendency. The MPC was 22, which is somewhat elevated, but the ruler and total acid number were very good. In this case, a different oil additization technique was used to enhance the solubility of the fluid. And again, the results were very positive. The green arrow here on this slide indicates the point at which the additive was used. The bearing temperatures stabilized very nicely, and there have been no excursions in the past year since this procedure was performed. So in summary, again, bearing temperature excursions can be certainly be a reliability problem in high-speed turbo machinery. Analysis of bearing temperature trends has shown promise as an indicator of oil-related deposits. Remember, the analysis, the routine oil analysis, even advanced oil analysis can be misleading and not detect the real issue. And so these mechanical and oil chemistry approaches have shown promise in addressing and correcting this problem.
Hey, Corey, if I could just add one last thing. You know, a lot of times we'll look at something and say, oh, how can I apply that to me right now? And I just recommend to anybody looking at this saying, oh, I want to explore this. First of all, pull your temperature data, take a close look at it, see if it's trending upwards, up above that 180 range, getting into the 200 range, and see if it has that sawtooth pattern. If it does, and you notice, hey, we could have some sort of temperature excursion, or this isn't going to make it to its you know, next 4 years before we can have an overhaul on this thing, then reach out to you know, somebody that can help, right? So if you're dealing with adding something to your oil, the oil manufacturer should definitely be involved. Otherwise, you'd be dealing with warranty concerns and things like that. So just reach out to those that are versed in this, and it is something worth exploring.
Yeah, great points. Cody, thank you again for helping with this presentation today.
Yeah, thank you.
Very grateful for your support. Thank you all who were able to tune in for this presentation. Again, please feel free to reach out to Cody or myself if you'd like more information. We are happy to share this research and collaborate on continuing to understand what is going on with this phenomenon. This was a pre-recorded presentation, so unfortunately we will not be there for the live Q&A, but if you have any questions, you can give those to the moderator of this presentation and they will get them to us. Thank you again and have a great day.
Thank you.